All right, let's see if you did the other ones correctly. These are solutions to the other activities. Remember to always divide by the lowest prime number. Always divide by the lowest prime vector. All right, I think this was the last one. Please try this. Give yourself 5 minutes. Press pause. And now press play after you've done it for 5 minutes. Try that. Give yourself 5 minutes again. And then check solutions. All right, let's talk about the lowest common multiple, and I'm going to show you how to find the lowest common multiple through factorization or prime factorization. And the lowest common multiple is simply the lowest multiple between given vectors. To find the lowest common multiple, you need to prime factorize the given numbers. Highlight the common prime factors. Represents the common prime factors once in the multiplication to find LCM. And if you have a common base, represent that base once and only take the highest exponent of that same base. For instance, if I ask you to find the lowest common multiple of 6, 12, and 18, you will first prime factorize 6, which is 2 times 3, then prime factorize 12, which is 2 squared times 3, prime factorize 18, that'll be 2 multiplied by 3 squared. What will be your lowest common multiple? You'll realize that 2 is common amongst all the products that you were given. So it will be part of our LCM, but only the 2 with the highest exponent will be part of the LCM. And the 2 with the highest exponent will be 2 squared. So 2 squared will be part of the LCM. 3 is also common, but only 3 with the highest exponent will be part of the LCM. Therefore, we'll only take that 3 squared. Multiply the 2 to find the product, and your LCM will be 36. Now, we need to find LCM of 2, 6, and 11. You have to prime factorize each of those. When you prime factorize 2, it'll just be 2. When you prime factorize 6, it'll be 2 times 3. When you prime factorize 11, it'll just be 11. And you'll realize that 2 appears twice, and only 2 that has the highest exponent will be part of your LCM. In this case, both of them are to the exponent of 1. Therefore, only 2 will be part of your LCM. 3 will also be part of your LCM because that is a different base. 11 will also be part of your LCM because that is also a different base. So you just multiply all of them to get your LCM, which is 2. 2 will be represented with the exponent that is the highest. In this case, the highest exponent will be 1, because please note that whenever you're given a number and there's no exponent written for that number, or written for that base, its exponent will always be equal to 1. Multiply all of that, it'll give you your LCM, and in this case, your LCM will be 66. Now, do the classwork quickly. Give yourself 20 minutes. Pause, and then press play after 20 minutes. All right. Solutions to that classwork, we need to find the LCM of 8 and 20. You'll first have to prime factorize 8. That will be 2 to the exponent of 3. Prime factorize 20. That will be 2 squared times 5. You will realize that 2 is common amongst the two given products, but only 2 with the highest exponent will be part of your LCM, which is 2 cubed. 5 is a different base, therefore it will be represented once since it's the only base and there's no other common 5. So it'll simply be, your LCM will simply be 2 cubed times 5, which is 8 times 5, and that will give you 40. Okay. What about 21 and 49? You will need to prime factorize 21. 21 will simply give you 3 multiplied by 7. And 49 will give you 7 squared. You'll realize that 7 is a common base, but there is no base. 3 is not a common base, so 3 will just be represented in your LCM. But only 7 with the highest exponent will be part of your LCM. In this case, it'll just be 7 squared. So your LCM will be 7 squared multiplied by 3, which is 49 times 3, and that will give you 147. We need to find the LCM between 3, 9, 12, and 60. You will have to prime factorize all of those given products. So I'll start with 3. 3, when you prime factorize it, it'll just give you 3. Prime factorizing 9 will give you 3 squared. Prime factorizing 12 will give you 2 squared times 3. And prime factorizing 60 will simply give you 2 squared times 3 squared times 5. 3 is common. We are going to take only the highest exponent of 3, which is 2. In this case, only 3 to the exponent of 2 will be part of your LCM. 2 is also common, but we'll only take the highest exponent of 2, which is 2 squared. And obviously 5 is not common. That will be part of your LCM. Therefore, your LCM will be 2 squared multiplied by 3 squared multiplied by 5. And that will simply give you 180. Remember, when you have a common base, you represent that base once in your LCM, but you only take the highest exponent of that base. Okay. Let's find the LCM between 1545 and 270. I will start by prime factorizing 15, which is 3 times 5. Prime factorize 45, which will simply give you 3 squared times 5, and prime factorize 27, which will give you 2 times 3 cubed times 5. 2 is not common, therefore it will be part of your LCM. 3 is common, it will be part of your LCM, but only 3 with the highest exponent, and the highest exponent of 3 is 3 in this scenario. 5 is common, and you will take the highest exponent of 5, which is just 5. And when you multiply all those prime factors, you will get 270. So 270 will simply be your lowest common multiple. All right, now it's your turn. Please try exercise 1.9 in your mind-born textbook. It's exercise 1.9 in your mind-born textbook. I think it's page 76 or 77, I'm not sure. Okay. Try it out, and all of it actually. Just try the whole exercise. Okay. Next, we're going to be doing the highest common factor. Now, a factor is simply numbers or terms you multiply or divide in order for you to get a product or the quotient. Note that here you will be given the product and you will need to prime factorize in order to find the higher common factor. Steps to follow. Prime factorize each product. I did show you how to do this using a calculator. You just go to your calculator. You press the number that you want to factorize. I will give you an example when we do the next one. Okay. Highlight the factors that are common, and only the factor with the highest exponent, the lowest exponent, will be part of your HCF. Only it must be a common factor. So it must be a factor that is common amongst all the given products, and only the base with the lowest exponent will be part of your highest common factor. Then if you have more than one common basis, you will just have to multiply all of them. But each base that becomes part of your HCF must have the lowest exponent. It must have the lowest exponent. Okay, let's do it practically now. Let's find the highest common factor between 14, 21, and 35. So this is what you are going to do in your calculator. You will simply go to your calculator. If it's a Casio calculator, I don't know how to do it using other calculators. Okay, and then you will simply make sure that you have removed everything in your calculator. you are going to punch in 14 and then press the equal sign. You will still see 14 in your screen. Then you go to the top left of your calculator. Somewhere in the top left. Press the shift button. And then count 1, 2, 3, but the third button, and then there's another button here, which is something like this. On top, it's written fact. That fact stands for factorize. Immediately when you press that, so you press shift and that button, it'll prime factorize 14 for you. And in your screen, you will see 2 times 7, okay? Do the same thing with 21. So you make sure there's nothing on your screen. You press 21. Unfortunately, I haven't installed my Casio calculator here. I always forget to install it. You press 21 and then you press the equal sign. In your screen, you will still see 21. I know with my cell phone, I don't have to go through this. I just press 21 and press shift fact. It does it for me. So it's 21, equal sign is still 21, and then you press shift and then you press that button that I told you about, which is fact, and it will factorize 21 for you. And in your screen, you will see 3 times 7. Okay, do the same thing with 35. You realize that the only common base here is 7, and 7 will be the highest common factor. Well, I can't take the lowest exponent of 7 because all these 7s that are given have the exponent of 1. Okay. 27, do what I told you earlier on. So you're going to punch that into your calculator, 27 equal sign, and then you press shift, fact. It'll factorize 27 for you, which is 3 cubed. 45 will be 3 squared times 5. 72 will be 2 cubed times 3 squared. Only a common base will be part of your HCF. So 3 is the only common base, but only 3 with the lowest exponent, which is 3 squared, will be your highest common factor. Here we'll have 2 squared times 3, and then we have 2 cubed times 3. So now we have 2 common bases, which is 2 and 3. So 2 will be represented as part of your HCF, but only the 2 with the lowest exponent will be part of your HCF, which will be 2 squared. And the 3 will also be part of the HCF, but you only 3 with the lowest exponent, which is 1 here, will be part of your HCF. You just find the product of the 2 to get your highest common factor, and your highest common factor will be 12. All right. Prime factorize 38. 38 will simply be 2 times 19. 57 will be 3 times 19. And 95 will be 5 times 19. The only common base here is 19. So that will be your highest common factor. Prime factorize 10, it'll be 2 times 5. Prime factorize 15, it'll be 3 times 5. 105 will be 2 times 5 times 7. 5 is the only common base. Only the lowest exponent of 5 will be part of your HCF, which is 5 to the exponent of 1. Therefore, 5 is just your HCF. Now, try your classwork from your mind bond textbook. That will be 1.10. I don't remember the page, but I think it was page 77. I hope I'm not wrong. Exercise 1.10. All right. All I can say for now is that, hold on. Enjoy the rest of your afternoon. And the next time in the next video, we will be, let me just do it now, actually, squaring roots and cubes, okay? So when you square roots and cubes, I'm just going to do it in a simple way. You can write these notes. It'll give you the steps on what to do. For instance, if they say I'm a square 576, I'm firstly going to prime factorize that 576. And obviously, they'll tell you that you need to prime factorize first using the ladder method. So you will prime factorize that. And that's what you will get. Okay. Now, when you simplify this, 576 in this case will be written as 2 to the exponent of 1, 2, 3, 4, 5, 6, multiplied by 3 to the exponent of 1, 2. But we are finding the square root of this entire thing, okay? Note that you can distribute the square root. By distributing the square root means that you can give each factor its own square root, or you can give each factor its own cube root, or you can give each factor its own fifth root, only if those factors are either multiplied or divided. If they're added, you cannot distribute the square root. And I need you to understand what the square root simply tells you. The square root simply tells you that if I have the square root of x to the exponent of n, when I square root that, I'm simply dividing the exponent. So I'm simply taking the base, but I'm dividing its exponent by 2 if it's a square root. If I have it as a cube root, it means that I'm taking the exponent of the base and I'm dividing it by 3. If I have the fifth root, it means that I'm taking the exponent of the base and I'm dividing it by 5. If I have to find the seventh root, it means that I'm taking the exponent of the base and I'm dividing it by 7. It goes on and on and on. Okay, so if I have, let's say, the mth root of x to the exponent of n, this will simply be x to the exponent of n divided by m. Okay. Similarly here, I will start by distributing that square root. So I will give 2 its own square root, and then I will give 3 its own square root. Now the square root simply says that I must take the exponent of 2, which is 6, and divide it by 2. Again here, the square root tells me that I must take the exponent of 3 and simply divide it by 2. So I'll end up having 2 to the exponent of 3, because 6 divided by 2 is 3 times 3 to the exponent of 1. 8 times 3 will give you 24, which is your solution in this case. Okay, my time is nearly up. Let me just make sure that everything is correct. And I would like to go through the next exercise as well, okay? I did it slightly differently here by just raising each base to the root number. So if the square root, if I'm given the square root, I'll raise the bases to the exponent of 2, and the square root and those 2's will just cancel out, okay? You can follow this method, or you just follow the method that I told you, that I just taught you, which is way better than this. And I think it's more progressive because that's how you will be dealing with the roots moving forward. Okay. Oh, let me finish this quickly. Let's find the cube root of 216. You first prime factorize 216. And the product of prime factors, you write it in exponential form. So this will simply give you 2 to the exponent of 3 and 3 to the exponent of 3. Now, what does that mean? I'm going to first distribute the cube root. So I'm going to give 2 to the exponent of 3 its own cube root, and then I'm going to give 3 to the exponent of 3 its own cube root. Remember from the previous example, cube root tells you that you must take the exponent and divide it by the cube in this case. And I'll do the same thing. I'll take the exponent of 3, which is 3, divided by 3. And this will simply give me 2 to the exponent of 1, but we do not write it at 1. Remember, if the exponent is 1, we do not write it. And I'll just write 3 to the exponent of 1. We do not write it. So this will simply give me 6. Okay. All right. This is simply exercise 8 from your ABC textbook, if you're using ABC textbook, which is also a very good textbook. I actually interchange. I use Mindborn textbook and ABC textbook because they're really, really good. Both of them are really, really good. Check it out, okay? And I'll just give you the solution to this one. Well, it's not just to this one. I'll give you the solution to the next one as well. Pause and try it first for 5 minutes and check the solution. Square root means that you must divide the exponent of each base by 2. Okay. Pause and try it first. Prime factorize. You will get 2 to the exponent of how much in this case? Yeah, those are lots and loads of 2's. Okay. So this will simply give me how much? Let's see. It's 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So this will be the square root of 2 to the exponent of 10. The square root tells me that I must take the exponent and divide it by 2. So I'll take 10 divided by 2. This will simply give me 2 to the exponent of 5. And 2 to the exponent of 5 is 32. Try this out. And that's the solution. Pause and try this out. For 5 minutes. Now you can press play after 5 minutes. It's 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. Okay, I'll just show you an alternative way. So you could have just found the cube root of, I'm missing cube root here. Cube root of 2 to the exponent of 12. This will simply mean that it's 2 to the exponent of 12 divided by 3. 12 divided by 3 is 4, and 2 to the exponent of 4 is 16, okay? All right. The next topic will just be ratios, and I'll still be using the Mindbond textbook as well as the ABC books for grade 9, for grade 8, as a matter of fact. And that is just a quick definition of what a ratio is and how we can simply write ratios, okay? and what writing a ratio in simplest form simply means. Check out the next video for more on ratios. Khotso.